In this exercise, we're going to be looking at a list of African countries, an African countries tour, and we're going to be looking at that with tests in Ruby. We're going to be doing a binary search tree. So let's get started, and let's create our African countries tour directory. Let's go into that. Alright, so let's get the test going straight off the bat. So we're using rspec. Let's do the quickest we can to get this test running. A few seconds. Okay, split my panes. And the test is running. Okay, so our infrastructure is working. Alright, so let's actually put something in here, put some code in here. So let's describe what we're doing here. So this is, let's just start off. I'm not really sure where to start, so let's just start with, we're going to need a binary search tree. So let's just have a test that does that. So we'll say expect our tree to be. Sorry to be poetic. Alright, and let's set up our tree. Just do a local variable here. Alright, tree.new. Simple enough. Fails because we haven't defined tree, of course. I'm just going to put the app code in a spec just for convenience for this exercise. So there's our tree. So that signature works now. That passes. Doesn't actually do anything, but it gets us one step closer. So we have a tree, and this is for a list of countries, list of African countries. So let's put that. Let's put that next. All right. So we'll create our tree again. Take care of the repetition in a second, and we'll expect tree countries. Let's check how many we have. Let's say we expect that to be 5. That's the exercise. There are 5 countries, so that doesn't exist. So we need an accessor, an attribute accessor, to read and write or get and set the countries. Alright, so that does that. We don't actually have any of the countries because we need an initialize method for when we create a new one, new tree, to actually set those countries up. So we'll do that right in here. We'll set up the countries. So we'll pick Sudan, Egypt, spell it right, Zaire, Botswana, and Morocco. Okay, so that's our 5 countries. So that passes, good. Alright, so the next test, let's try and take another step. It's binary search tree for countries, and let's start off at the root. All binary search trees have a root node, so let's set that up. Alright, so let's create our tree. Actually, let's just think about our root node for a second. That's all we actually need to make this pass. And it would fail because node would not be known, so let's just go ahead and create that class with no need to run the test in between. So we would create that node, and then take that node and add it into our tree nodes. So try tree nodes plus equals the root node. And now we would expect our tree nodes. So we've added that one in. Count to equal 1. Sorry, 2. No, let's just. We're gonna make this fail. Not quite sure. Let's run this. Oh, wait a minute. Yes, we need to add that attribute. And actually, when we initialize it, when we set up a new tree, we need to set it to be an empty array. We're going to be adding to that. Okay. Nodes doesn't exist. We actually need to for an array. Actually, that wasn't it. But let's see, we got a tree. Yeah, we need to set up a tree. Okay. And it was actually 1, yeah, not 2. Okay, that should get saved. Sorry, should actually pass. And let's set another expectation that it actually did it what we expected. So let's look at that 0 node. Let's look at its its name basically. Well, actually, we could country name. Let's call it country name. Let's just name it right here. And that should be the first one. That should be Sudan. Let's make sure that actually did that. And we'll leave that as a an attribute on node. So let's set up the getters and setters for that country name. And again, we'll need to set it up in our initialize when we create a new node. We'll pass in the name and we'll say that our instance variable country name is equal to that. Okay, let's run that. And actually change the signature of this. So we said we would pass in. So we put the countries inside the tree just for convenience. We would normally put data in a class like that, but it's that little array in there called countries. So we'll just grab that, and that passes. All right. So now let's dry this up a little bit. Let's take that tree we're creating every time and do a lazy evaluation variable for that. Actually, we don't do it before. We just do the let. We just do it like that. Now I can get rid of that. Get rid of that. Get rid of that. Yep. Okay. So get rid. Go. Okay. Passes. All right. So now, next case, we got the root node. Now we want to add a second node. It's fairly logical to the root node. Alright, so it's just going to get interesting. So, we're basically going to do some of this stuff again. So let's set up our root node, add it to the tree. It's like a setup here. We can extract that, we'll leave it for right now. Focus on. Now what we want to do is we want a new method called add node. It's going to have some logic into it. We're going to pass in the node that we want to add to, which is start off with the root node, and we'll pass in the next country, which is tree.countries of 1. And this time we would expect our tree.nodes count to be 2. Right. And let's make sure it actually did that the way we thought. So it's going to add Egypt, and that's going to be on the left. So the Sudan's left country name is going to be Egypt, and the right, this point, the right country name would be blank or nil. I think let's try doing that. A couple of checks here. All right. I think try nil. Let's just try it. All right. That looks good. Let's save that and run that. The add node doesn't exist. Okay, so this is going to be actually our method. It's got a bit of logic here. So here's our add node. We're going to, there's our signature. So it's going to be passing in a node and the country. All right. So passes in the node and the country. All right. Now, this is where the actual algorithm comes in. So, if the country that's been passed is less than this current node's country name, then it's like on the left-hand side. And if that left is nil, then it doesn't exist. So we want to add. We want to concatenate into the array that node, the current node's a new node, but we also want to set the current node's left to be that new node, and we can kind of do that in Ruby with a compound statement like that. All right, so that's that. Otherwise, so left was not nil, left actually existed. And in that case, we have the recursive case. If we want to track, we go to that node, so we pass it in as the current node's left recursively into this function. And so if the country is greater than, which is basically what this else is here, if the current node right is nil, same as we did up there, basically. We want to either add it if it's nil, or if it's not, we want to travel down the right hand side, so we recursively call add node again and we pass it in the current node's right and the country. Alright, so that is add node. Standard algorithm really there for doing that. So let's save that, try to run that. Okay, current, sorry, it's not actually called current node. Well, I'm calling it current node here, but it's node. We can just call this node. Node. I didn't even call it current node, I just called it current node. Okay. So that's all node. So left, we started referring to this left and we didn't actually add it in our node. So let's add left and right attributes that we can read and write from. Oh, and our spelling. Sometimes the test itself is wrong. So we actually, the data itself is wrong. So we got our, don't know where we set up the data there, corrected that. And country name here. Oh, we can't actually have country name because right itself is nil. That's the problem here. So let's get rid of, and then let's just check for that. So right, okay, that was good. All right, so one more test. So we've added a root and a second node. And another requirement that we had would be, or the sort of the ultimate requirement, or the overall requirement was to show that a country existed and another country did not exist. So we're going to set it up, set up our tree. We set up the way we have before. Actually, let's take this. We're actually going to, we want to do some stuff that's common with these cases here. So I'm going to do describe and indent these cases so that I can dry up some of the stuff that's going on just for these cases. Like we create a new node in these cases, whereas in the previous ones we didn't. So now, because we've done that, we can put our before each, shorthand before do, before each do. And we can put our node there, so get rid of that. And we could also put our, sorry, we'll use let, not before, so let's just set that using let. And we'll get rid of the before in the end. Okay. Spacing. Okay. So get rid of that and that. Let's just make sure it works. Yes. All right. So actually go. The next line. Sorry. Whoops. Okay, that works. Get rid of that. Get rid of that. And we could also do this. We could do as a before. Okay. Alright. And get rid of it there. Run that. And it passes. Okay, that's good. Alright. Now, let's see. Got a couple of expectations. There's two expectations here, but there's no code, which is a bit off. Now this looks odd. Because we've set it up immediately to pass. Come back to that. That's really bugging me. It's gotta be, how can I get, well, I could try to think if I could just do another case. This is the case. Let's just do this case while it's on my mind. Alright. So it shows that Zaire exists and blob does not. That's what this case is going to be. So let's actually, you know what? Now I've just realized I could do it like this. I could put this here, there, and sorry, just put that there. Countries, two things here. Alright, let me just this first. Alright, because it's actually just tree. So we want to go through the whole of the tree, looking at through all of the countries. We're going to add all the countries in here. So we're going to do a little method here to add all 5 countries in. So let's make sure that works first of all. So let's expect our tree.countries.count to equal 5. Alright. And not just that, but let's also make sure that our this method, so when we load up the array, we load up the array and then we have these methods, the tree, sorry. We're going to have this method called node exists, and we're going to try it out for Zaire. It's a predicate method, so it's got the question mark, and let's put the actual description of what we're trying to do here. Okay, so Zaire should be, and back not a country to not be, so those are some really good conditions. We're actually missing parens there, let's fix that. Okay. So node exists does not exist yet, so let's create that method. Now this is pretty interesting because it's going to be very much like add node. Let's just look at the signature. Yeah, we're passing in the node, passing in the country. So it's kind of similar to add node so far. So for this, it's again kind of similar. We're just going to keep it separate for now. And there might be some refactoring we can do with it if we keep it separate. So until we know it's the same, let's keep it separate. So basically the same kind of code up to this point, but now if that is nil, then it doesn't exist. We just want false instead of adding that new node. It's kind of simpler. Otherwise, we're going to travel down in the same way. The tree on the left, if there is a left country already. So we'll pass that back in recursively. So similar for the right, we're going to check if it's nil. So we'll do that here. Right's nil, that's false. Otherwise, we're going to recursively call node exists, passing the current node.right in the country. Here, node exists, current node.right in country. Alright. Put our end there, and an end there. And I think that's good. Highlighting's good at least. So that's a little bit simpler. It's kind of similar. And we do need that one condition for the true, of course. If we actually find the country is our current node's country name. So otherwise it would never be true. Alright, so I got, and that's actually again not current node, just node. Alright, to get our names right. And that passes, great. Alright, I think there's something I think we can refactor that. Let's just take a look here. I think we could do a ternary. This looks like the structure. We could just say that's true, give us false. Otherwise, which is like our else here, do the recursion. So this is kind of similar to this line, except the left's a right, so we could just change that to get it right. Change that, and that's it. And then we'll just get rid of these other lines. And that one. Save. Oh, wait a minute. Yep, okay. Let's run this. Nice. Alright. So it's looking pretty good. Adding in all of our countries. We can see if nodes exist, and that passes. See if there's anything else we can clean up here. I actually think that's pretty good. Alright, thank you.